Howdy and welcome back. So we'll go ahead and close out this lesson with some guidance for argument passing. As you can tell, it's getting into the evening here. I'm starting to turn ghostly. I apologize for that, but the lighting's kind of poor here. So anyhow, we'll begin. So here's some guidance for passing arguments. At this point, you might be wondering, well, when do I use constant pass by reference to const? When do I use pass by value? What about plain vanilla pass by reference? Well, here's some kind of direction to help you pick and choose. So pass by value for small objects, such as the primitive built-in types. A simple copy of a small object is going to be effective. Don't pass by reference unless you've the reason to do for these small objects. One reason to do so was when we showed that swap function. Use pass by reference to const for large objects. So think any user-defined type you're creating within your program. This could include structs or otherwise, standard library vectors, standard library strings, maps, etc. Reference to const, though, it means no copy will occur. You'll be able to interact with the data just like you would otherwise. It'll be read-only, though. Use vanilla pass by reference only when you have to. This one should really, really be used sparingly. And you should always favor returning a result rather than modifying an object through a reference argument. And that's partly because it's not always clear that such modification is taking place. In a function such as swap, the name makes it kind of intuitive that you'd be swapping those two, values and actually affecting the underlying arguments. But in other cases, it's not always clear. So in the last video, I promised, well, what is a way to kind of get an additional layer of security here to really ensure that whoever's using this realizes that the objects being passed are going to be mutated. So think vanilla pass by reference without doing so. So an example of that. I didn't like this example over here, but the same thing kind of holds to it. What I'm going to do is continue our example with swap. Now notice here my definition of swap, I'm passing by value here, but the parameters are pointers. So here's where it gets fun. Let's say I have a main function where I have int a 7, int b equals 11, and I want to utilize the swap function. Now to make it, and notice I wrote that in, this is all in uppercase here. I know my writing's bad. I'm trying to make it a little clearer. Anyhow, I could utilize the swap function by having kind of the same perks of pass by reference, but doing pass by value with pointers. And here's what happens. You can pass in the address using the address of operator of A, address of B. At this point, it is beyond clear that there's potential for these arguments to be mutated. You have to explicitly pass their address to this function. So what that means is, let's just run through this in our little diagrams, is in main, let's say we have A takes on 7, B takes on 11, and then we hit this function call to swap. Now in this case, I should have used other names, but in this case, A is going to be a pointer to that object, to the object for which B, okay, we really need to use other parameters. Let's go I and J, I, J, I, J. So in this case, A in the swap function is simply going to be a pointer to I in main. B is going to be likewise. It's going to be a pointer to the object to which J is bound in main. And we can like, if that helps you to put these in boxes to show that they're objects, that works too. Now notice we're doing the same procedure in swap. We initialize temp and it gets the value in the object to which A points. We dereference A, and when we dereference A, we're actually accessing the value stored in I because A points to I. Likewise, when we dereference B, we get the object to which B points to, in this case, J. Now notice making the assignment to A causes the value in I to take on, in this case, 11. Notice now when we then make the following assignment to B, we're operating on the object bound to here by J, and that will take on 7. And there's our swap function. So if you need like plain vanilla reference because you're doing something where you're actually mutating the arguments, it is very clear and hard to miss if you're having to pass in the address of some sort of arguments to this function. Now, if you look up here at our previous rendition of this implementation, if I can find it, when you call swap, when it's written or defined as so, and I is equal to 7, J is equal to 11. If you do swap I comma J, notice how easy it's just to bind A and B to I and J respectively. And it's not as clear, though the name's communicating here quite well, that the values of I and J are going to indeed change. So that concludes our today's lesson on references and passing arguments by reference. I hope that this was informative and that these topics came across as hopefully clear. So with that ado, if you have any additional questions, always feel free to post to the forum. I'm happy to provide any sort of clarification where it may be needed.